Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 16 to 20 of the Accuplacer Elementary Algebra Practice Test. This is the updated version. Don't forget to check out our interactive practice tests by following this link so you get access to more practice problems like this. At any point in time in this presentation, if you have any questions, just include it in the comment section below, and we'll be more than glad to support you. All right, let's take a look at our question number 16. We have a system of linear equations, okay? And the question is, how many solutions x, y are there to the system of equations above? Now, something you want to note concerning the solutions of systems of equations are as follows. If you have a system of linear equations, you can only have no solutions, one solution, or infinitely many solutions. Now, take a look at this system right here. How do you know that it's a system of linear equations? Well, it is because it is in the form ax plus by equals c. And then we can call the second one dx plus ey equals f. This is the standard form of the equation of a line. We know it's linear because both variables have a degree of 1, okay? So that gives you a system of linear equations. Whenever you have this scenario, you can only have you can have no solution, one, or infinitely many solutions. Those are the only possible outcomes. With that in mind, we can eliminate option C because it's impossible to have two unique solutions when solving systems of linear equations. All right, now let's go ahead and solve the problem. There are two ways you can do this. I'm going to show you two methods, okay? The shortcut method is a little bit more abstract, but it's really fast. And then I'll show you the other method, which involves solving the system. Now, if you do not like the shortcut method, that's fine. You just solve it, okay? Because it's important to know how to solve system of linear equations. So shortcut method involves studying the coefficients and constants of both equations. Now, if the coefficients and constants of one equation is a multiple of the coefficient and constants of the other, in that case, you have infinitely many solutions. So for short, I'm going to write coefficients and constants are multiples, okay? If they're multiples, in this case, you have infinitely many solutions. All right, let me give you an example of what I'm talking about. So let's say you have 3x plus 2y equals 2. And the second equation is 9x plus 6y equals 6. Now, what do you notice here? If you look at the coefficients and the constant of equation 1, if you triple them, what do you get? You get triple this, you get 9, you triple that, you get 6, you triple that, you get 6. So in a scenario like this, you have infinitely many solutions because the coefficients of x and y and the constant of 1 is an integer multiple of the other. All right, case number 2. If the coefficients only, okay, coefficients are multiples, guess what? You have no solution. Okay, you have no solution. Let me give you an example of what that looks like. So you have this scenario right here. What if I change this 6 into a 1, for example? Okay, in that case, the coefficients are constants because when you are multiples, because when you triple these coefficients, you get this. But when you triple 2, you do not get 1. So in a case like this, you have no solution. And case number 3, if you have neither 1 nor 2, either 1 or 2, guess what? You have exactly one solution. All right, so let's apply this shortcut to this problem. If you look at the coefficients, are they multiples? The answer is yes. If you double the second equation, if you double the coefficients, guess what? You end up with the coefficients of the first one. But are the constants multiples? If you double 2, do you get 5? The answer is no. So in this case, coefficients only are multiples of each other. So guess what that means? You have no solutions. Your answer is option letter A. Okay, so that's the shortcut. Now, let's say that doesn't make any sense. Let's use method 2, which is just solving the system. Okay, method 2 involves just solving the system. Now, before you solve a system of linear equations, you should know exactly what kind of solutions you are going to get. Okay, so if you have no solution, what does that look like? No solution involves having a false statement. Okay, so no solution is a false statement. And it's when you end up with something like 3 equals 1. Is that true? No, that's false. So if you have a false statement when solving a system, then there's no solution. All right, in cases like this, the variables cancel out, okay? You just end up with numbers. Now, if you end up with, if you have one solution, what enables you to have one solution? In that case, if you have an exact answer, either for the x or y, then you have one solution, like you end up with x equals 3 and y equals 2, then that's fine, okay? You can also have infinitely many solutions, infinitely many, and that occurs when you end up with a true statement that's always true. All right, so we know 3 is not equal to 1. How about 3 equals 3? When is 3 equal to 3? Always, right? So whenever you solve a system and you end up with a true statement, variables canceling out completely. In that case, you have infinitely many solutions. All right, so let's see what happens when we try to solve this equation, okay? So we have 2x plus 6y equals 5, and x plus 3y equals 2. Now, I want to use a method of elimination because that's the quickest method whenever you're presented with the system in standard form, okay? So you look at the coefficients and ask yourself, which one is it easier to create opposites? So like the x's, this is 2, or I can easily make this the opposite of 2, -2, or this is 6, I can make this -6, okay? So pick one, let's pick the x's. I want to create opposites with the x's, so I'm going to multiply the entire equation by -2, okay? So what does that yield? We have 2x plus 6y equals 5. Equation 1 remains unchanged. Equation 2, you have -2x. Please distribute this negative to the entire equation, okay? Minus 6y equals -4. Now, why on earth am I creating opposites? Because when you combine opposites, they become 0. Okay? So my goal is to eliminate the x's. These add up to 0, but take a look at an unintended consequence. The y's also became opposites, and when you combine it, you end up with 0. So the left side of the equation cancels out completely. The right side, 5 minus 4 is 1. Now, we know it's not option 1 because there's no variable here. It's either true or false. Is this a true statement? Is 1 ever equal to 0? Never. This is a false statement. So guess what that means? That means you have no solution. Okay? So this is the method 2, actually solving the system to see what you get, and it agrees with our answer that we got when we used the other method, which was the shortcut method. All right, let's take a look at question number 17. It reads, which of the following is a factor of both x squared minus x minus 6 and x squared minus 5x plus 6? Okay, so what we're simply going to do here is factor both expressions and see which factor they have in common. Okay, so let's start with x squared minus x minus 6. Now, there are different ways to factor a quadratic trinomial of this nature. The method I like to use is the AC method because of how effective it is. You can also use the asterisk method, the box method, guess and check. All those methods work, but this is the best method from my experience, okay? So you can put AC on the top, -6, and B on the bottom, -1. And then you ask yourself, what two numbers multiply to give you -6 and add to give you -1, okay? So let's try 2 and 3. 2 and 3, the sum has to be negative, so the bigger has to be negative. Okay, so 2 times 3 is 6. 2 times -3 is -6. 2 minus 3 is -1. Perfect. So what we'll do is just take the 2 and the -3, and we insert them into parentheses with the x's. So x was 2 times x minus 3. These are the factors of this quadratic trinomial. All right, let's take a look at the second one, x squared minus 5x plus 6. We're going to factor it using the same algorithm that we used in the previous expression. AC in this case is 6, and B is -5. Okay, now please pay close attention to the signs anytime you're filling out the x game, make sure it works, okay? So what two numbers multiply to give you 6 and that to give you -5? So let's see, what if we try 2 and 3 again? The sum is negatives and is bigger than both of them, so both of them have to be negative. And when you multiply -2 and -3, you get +6. All right, so we have x minus 2 times x minus 3. Okay, so what factor shows up in both factored states? X minus 3 is a common factor. Okay, so since it's common, we can simply conclude that x minus 3 is a factor of both x squared minus x minus 6 and x squared minus 5x plus 6. And that's because it's the only quantity that shows up in the factored form of both quadratic trinomials. Our answer for question number 17 is option letter A. All right, let's take a look at question 18. It reads 10x to the 6th plus 8x to the 4th divided by 2x squared equals. Now, one thing you want to remember is that your quotient has to do with your quotient property of exponents. Anytime you're dividing exponents with the same base, you subtract the exponents, all right? So for example, if you have a to the x divided by a to the y, guess what you're going to do here? You're going to subtract the powers, x minus y. This is known as the quotient property of exponents, all right? So let's go ahead and apply that here. We have 10x to the 6th plus 8x to the 4th divided by 2x squared. Now, since both terms in the numerator are being divided by 2x squared, we can split up this fraction, okay? So we can write this as 10x to the 6th divided by 2x squared plus 8x to the 4th divided by 2x squared. Now remember, whenever you're adding fractions, the denominators have to be the same. Okay, that's why we have this form when it's combined. But when we separate them, both of them have to have their own denominator in such a way that both denominators are identical. Okay, now why did I break it up? It is because I will have to apply the quotient property of exponents independently to the 8 and the 10x to the 6. Okay, all right, so let's do the left side first. 2 goes into 10 5 times, so 2 goes into 2 once, 2 goes into 10 5. So we bring down the 5. And now what do we do with the x's, the variables? This is where we'll apply the quotient property of exponents. Okay, now the bigger number power is upstairs, so that's going to be nice. We're going to have our variable term upstairs in the numerator, and it's going to be 6 minus 2. Okay? Had it been 6 were downstairs here in the denominator, guess what? We'll have 5 over x to the 6 minus 2. So you always keep the variable where the bigger power is, basically. Okay? So this is nice because the bigger power is upstairs, then no reciprocation is needed. 8 over 2. 2 goes into itself once and goes into 8 4 times. So the result of dividing the coefficients, so the constant is 4. Now we're going to apply the quotient property of exponents to the variable exponential terms again. Okay? So, well, these are powers, not exponents, exponential terms. So what happens when we apply the quotient property of exponents to these powers right here? You subtract, right? 4 minus 2. And then your final answer is going to be 5x to the 6 minus 2, 4, plus 4x to the 4 minus 2, 2. All right? So our final answer for number 18 is option letter C. All right, let's take a look at question number 19. It reads, a rectangular yard has area 96 square feet. If the width of the yard is 4 feet less than the length, what is the perimeter in feet of the yard? Okay, so one tip concerning geometry word problems. Anytime you're solving a problem, a geometry problem presented in a paragraph or text format like this, you always want to use a well-labeled diagram to help you set up and solve the problem. Okay, so that's exactly what we are going to do. Steps are as follows. We're going to sketch a rectangle, or give ourselves a visual representation of the scenario and label it as much as we can. We're then going to use the relevant formulas to set up an equation. We will substitute components into that equation using the information given, solve for the dimensions of our rectangle, and then use it to find the perimeter of the rectangle. Okay? All right, so let's do it. Step number 1, sketch our rectangle, our rectangular yard. The area is basically the enclosed space. Area is 96 feet. Dimensions, this is the width, and this is the length. Now, it's not drawn to scale, okay? So if this turns out to be smaller than this, don't get upset because I'm just drawing a random rectangle. All right, so there you have it. We have our figure. Now let's write down some formulas. What is the formula for the area of a rectangle? The area of a rectangle is given by length times width, okay? Now, there is a relationship, though, between the length and the width of this rectangle. It states here that the width is 4 feet less than the length. What operation is less than? Less than is subtract, okay? So to get the width, we have to take away 4 from the length. So the width is going to be L minus 4, okay? All right, so now what we're going to do is we're going to, let's state another fact. We also know that the area is 96. So what I'm going to do is I'm going to substitute equations 1 and 2. I'm going to substitute 2 and 3. I'm going to substitute their values into equation 1. All right. So for equation 2, I'm going to take L minus 4 and I'm going to plug it in for W. That's the first substitution. And then I'm going to take 96 and plug it in for A in equation 1. So we are actually making 2 substitutions here. All right? So let's make explicit what I just did. I'm going to enumerate my equations and then write a short remark. Equation 1, 2, and 3. So what we're going to do is substitute L minus 4 for W and 96 for A in equation 1. Bam. Okay. So when we carry out that substitution, we're going to end up with A becomes 96 equals L, the length, times, instead of W, we're going to replace that with L minus 4. All right, so let's simplify. We can distribute this L across these two terms in this quantity using the distributive property. So L gets distributed to these two. And we have L squared minus 4L. Ladies and gentlemen, this is a quadratic equation. How do we know? The highest degree is 2, and we just have one variable here. Okay, the variable is L. So when you have the highest degree of an equation is 2, in terms of just one variable, then you have a quadratic equation. Now, how do we solve quadratic equations? We want to start by putting it in standard form, okay? What on earth is standard form? Standard form is where it's set equal to 0 with the degree terms in descending order. Okay, so it's basically the form ax squared plus bx plus c equals 0. In this case, our variables are L. So in order to place this in standard form, I need everything on one side, okay? Since L squared and 4L are already on the right side, I might as well just subtract 96, have the constant, join them over there. So that results in L squared minus 4L minus 96 equals 0. What have we just accomplished? We have just placed the quadratic equation in standard form. Now we can solve. There are different ways you can solve this. You can use the quadratic formula, completing the square, graphing. You can also use factoring. Okay, so in this case, if you look at the options that we have, they're nice integers, so we're not dealing with any weird things here. So we're going to be using the factoring method. This is a factorable quadratic equation because of what the answers look like. Had it only had radicals or well, that's not possible. If we had just radical numbers in our solution, then there's a possibility that we can factor. Okay, so this is a good problem. It's a nice problem here that can be factored. So we're going to be using the x game as we did in one of the problems we just did. AC goes on top and B goes on the bottom. So AC is negative 96 and B is negative 4. All right, so now this is where you can actually literally get stuck. What are two numbers that multiply to give you 96 and add to give you negative 4? Okay, so what you're going to do here is make a T-chart. Okay, so make a T-chart, and then you're going to be finding the combinations of pairs of numbers that yield the product of 96, but when you add or subtract them, you get 4. All right, so to aid us in the process, I'm going to take 96 and I'm going to decompose it into a product of primes using my factor tree, okay? So let's start with, since it's even, I can pull out 2. 2 times what? 48. Divide 96 by 2, you get 48. Take out another 2, you get 24. Take out another 2, you get 12. Take out another 2, you get 6. Take out another 2, and you get 3. All right, so guess what? This factor tree, believe it or not, can help you generate a combination of pairs of numbers that we can test to eventually get our desired target of 4. So first one, 2 times 48. Well, actually, let's try this. 1 times 96. Can this combination give us 4? Absolutely. This gives us 95 or 97. That's way too big. Next, 2 times 48. 2 times 48. This combination gives us 50 or 46. No good. Now, what's the next pair? Check this out. 2 times 2, 4 times 24. Guess what? Gives you 96. So you go 4 and 24. See, isn't that nice? If you add these two, you get 28. If you subtract, you get 20. That doesn't hit the number we want, which is 4. So what's the next combination? 2 times 2 times 2 is 8 times 12 is 96. Okay, so 8 times 12 yields 96. If you add these two, you get 20. If you subtract 4, voila, this is what I'm looking for here. This is the combination. All right. So you see how helpful the factor tree is. Sometimes some students spend forever trying to figure it out, and they get the problem wrong. But when you use this approach, it's very easy to determine what pair works. Okay, so we have 8 and 12, and now we have to resolve the signs. The sum is negative, so the bigger has to be negative. Perfect. So we're now going to put it in. We have L plus 8 times L minus 12 equals 0. We're now going to use the zero product property to finish this off, okay? So basically, we have a product of two quantities that's equal to 0. Either the first is equal to 0 or the second is equal to 0. To solve the first one, to isolate the variable, you subtract 8 from both sides, and that yields L equals negative 8. The second one, you want to isolate L, so you just add 12 to both sides, and you end up with L equals 12. All right? Okay, now one of these works, one of them do not work. Is it possible to have a negative length? Like, can you use a ruler to measure length and end up with a negative value? The answer is no. Lengths are only positive, okay? So L equals 12 is one of our answers. This is not a feasible result, so we scratch that out since length cannot be positive. It cannot be negative. Okay, so we have our length. What else do we need to determine the perimeter of a rectangle? We need the width also, okay? So what do we know from equation 2? From 2, what do we know? We know that the width is 4 units less than the length. All right, so let's call that equation back up. So this is what will help us find W. So L, we substitute 12 there. And that tells us that W is equal to 8. We know our width and our length. We know the dimensions of our rectangle. Now, the perimeter is what we're asked to find. The perimeter of a rectangle is 2 length plus 2 widths. Okay, at the top and bottom and left and right. So if we substitute our results here, we have 2 lengths, 2 times 12, plus 2 widths, 2 times 8. All right, multiply, you have 24 plus 16, which equals 40 yards. So that's this is basically the perimeter of our rectangular yard. All right, let's take a look at problem number 20, the last in this review installment. It says, on Monday, it took Helen 3 hours to do a page of science homework exercises. The next day, she did the same number of exercises in 2 hours. If her average rate on Monday was P, exercises per hour, what was her average rate the next day in terms of P? All right, so steps. These are the steps we're going to use to solve this problem. Number one, we are going to write down the appropriate formula that relates time, rate, and amount of work that's been done. Secondly, we are going to apply that formula to both days, Monday and Tuesday. Next, step number 3, we're going to use the given information in this paragraph to make substitutions into our two generated equations. So we will end up with a system of equations. And then step 4, we're going to use the resulting system to solve for the average rate of the second day, next day, Tuesday, in terms of P. Okay? All right, so let's get started. Step number 1, what is the formula? What's a formula that relates the amount of work you do, your rate, and time? It's the ART formula. Amount of work you do is equal to rate times time. Okay? Now we're done with 1. We're now going to write our Monday and Tuesday equations. Start with Monday. So for Monday, the amount of work that Helen does on Monday is equal to her rate of work on Monday times the time she spent on Monday. All right? Tuesday, the next day, using the same equation, the amount of work she does on Tuesday is equal to the rate at which she works on Tuesday times the time she spent completing the work on Tuesday. Okay, so now we have our two equations down. We now need to start extracting some relevant information from the paragraph, okay? So how long, let's take a look at her time for Monday. How long did it take Helen to do the work on Monday, to complete the exercises? So that's going to be time for Monday is 3 hours, okay? Now, how fast was she working? What was her average rate for Monday? Her average rate for Monday is kind of tricky. Let's go back to the paragraph. Says, if her average rate on Monday was P, you see that? So that's our average rate for Monday. So average rate for Monday is P. Now let's go to Tuesday. What was her time? How long did it take her to do the same number of exercises on Tuesday? The time for Tuesday was 2 hours. Okay, and her rate, how fast was she working on Tuesday? Now this is what we're asked to find in terms of P. So we're going to put question mark there as what we're going to be looking for. And another thing to note is that she did exactly the same amount of work on Monday and Tuesday. So amount of work she did on Monday is equal to the amount of work she did on Tuesday. So we're going to be making substitutions with all these pieces of information in 1 and 2, and then that will give us an equation, a system of equations we can solve to determine the rate at which she works on Tuesday in terms of P. All right, so let's go ahead and make our substitutions. So for Monday, I'm going to leave amount of work as amount of work. Her rate for Monday is P times her time for Monday, which is 3. Bam. And then her amount for Tuesday is equal to her amount of work on Monday, so I can make a substitution there, call that AM. Her rate for Tuesday is what I'm looking for, leave that unchanged. And the time she spends completing that amount of work on Tuesday is 2 hours. All right, so there you have it. Now we can make our equations look pretty, okay? So we have AM equals 3P, that's equation 1, and AM equals 2 average rate on Tuesday, that's equation number 2. All right, let me move everything to the left a little bit so we have some space. Okay, so let's label them equation 1 and 2. So this is 1 and 2. So since these equations have been solved explicitly for a variable, we can simply use the method of substitution here. Okay, so we're going to substitute 2RT for AM in equation 1 because AM is equal to AM and AM is equal to 2RT from equation 2, right? So if we carry out that substitution, what do we get? We have, let's make some space here. We have, instead of AM in equation 1, I'm going to have 2 times 2RT equals 3P. What are we solving for? We're solving for her average rate on Tuesday, R of T. So to get that isolated, you simply divide both sides by 2. And then your average rate for Tuesday is equal to 3 over 2P. Final answer for question number 20 is option letter D. Okay, her rate in terms of P is 3 over 2 exercises per hour. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the Accuplacer elementary practice test, to give us a thumbs up. Your positive feedback is very valuable and supportive to us. As indicated earlier, if you have any questions, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other great math tutorials such as this. And you can also take our interactive practice tests to review the contents you've covered in this presentation. More tips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.